Let's begin by looking at a graph to conceptualize finding the area between two curves. Let's assume we have a curve f of x, as shown here. Given the endpoints of an interval a and b, we want to find the area under the curve from a to b, denoted by the shaded region. Now let's assume we have a second function, g of x, that is less than or equal to f of x, and we want to find the area below it, as shown by the shaded region. Notice that this region overlaps with part of the region below the curve of f. So, if we subtract the region below the curve of g of x, we're just left with the region between the two curves. In other words, the area between the curves is equal to the area below f of x minus the area below g of x. Let's determine how to find the area of a region between two curves. Assume that we have two curves on a graph such that one curve f of x is greater than or equal to a second curve g of x over an interval from a to b. Then the area between the two curves is given by the integral of f of x minus g of x dx evaluated from a to b. Let's try a problem that involves finding the area between two curves. To try to get a better idea of the problem, let's begin by graphing the two functions. Recall that the area of a region between two curves can be calculated using the integral of f of x minus g of x dx from a to b, where f of x is greater than or equal to g of x. In this case, notice that on the interval from 1 to 5, f of x is greater than or equal to g of x. So, substituting our functions into the formula, we get that the area is equal to the quantity 2x plus 3 minus the quantity negative x plus 6 dx from 1 to 5. Simplifying the integrand, we get the integral of 3x minus 3 dx from 1 to 5. Now, let's integrate. We get 3x squared over 2 minus 3x evaluated from 1 to 5. Next, we can evaluate the result at the limits of integration. So we get the quantity 3 times 5 squared over 2 minus 3 times 5 minus the quantity 3 times 1 over 2 minus 3 times 1. Simplifying each term, we get 75 over 2 minus 15 minus 3 over 2 plus 3. Adding and subtracting, we get 24. Therefore, the area between the two curves is equal to 24. Notice that the area between the curves is a triangle, so we can check our answer by calculating the area of this triangle, but we will leave that up to you.